What's going on, guys? Today we're going to be reviewing some Nicaraguan cigars and some German beer. Just kidding. No, actually, we are discussing membranes. Stay tuned. What's going on, guys? So today we're making a little video on membranes. We have a Q&A, but people don't like to read. So we make a little video, and I've been told that my voice is puts people to sleep, to say the least. So we'll take this as an ASMR video where you can just listen to what I have to say, and maybe you'll learn something, or maybe I'll put you to sleep. So right on. What are membranes? Well, let's see. Wikipedia just classifies them as a method that uses nanometer size through pores to pass through a membrane. So it's a filtration system that is different from dead-end filtration. Dead-end is like filter paper, things of that nature. Dead-end filtration, you have a cartridge or whatever and a solution that goes in one pipe. Solids basically coagulate, clog up that filter paper or cartridge or whatever, and then a clean solution permeates through that paper or cartridge, right? And they can be depth filters like lenticular, but that's dead-end filtration, basically. Membranes are different. Membranes are different because we are not talking about size as much as molecular weight. So filter paper might be down to 0.2 or 0.02, 0.5 micron, and those sizes are for sterilization because they can remove bacteria and viruses at that size. This stuff is like way magnitude smaller than micron size, and we don't measure particles in size. We measure them by weight. So you can't really compare apples to apples, even though you can infer a few things, but hear me out. We talk in molecular weight. So we go down to regular filtration, micro, ultra, nano, and reverse osmosis. You've heard of reverse osmosis because it's what's used to filter water. And this technology is extremely popular in desalination plants because you can get down to such minute sizes that you can actually filter out 98% of the salt from salt water, and clean water permeates through those membranes. What other applications you've seen this? If you go to a supermarket, lactate. Lactate is lactose-free milk. It's actually made from cows, but what they do is they run it through a membrane, and the membrane is able to get the lactose out. Lactose is a sugar. So you can remove the sugar from the milk, and thus the milk is lactose-free, and it's for people who have sensitivities of that nature. My kids have that. So anyways, we use it to remove sugars. So same application. What about beer? Have you drank non-alcoholic beer? Some non-alcoholic beer is actually filtered through membranes to remove alcohol. We use similar membranes for desolvation. Isn't that awesome? So anyways, that's membrane filtration. And how does it apply to cannabis? So we have desolvation membranes, which is solvent recovery. They are awesome because they're a roto killer. They're a falling film, rising film killer because they cost a lot less than a falling film. And they typically use a small fraction of the energy, 5% of the energy or whatever. And so our smallest system can do, right now, it can do somewhere about 120 gallons of ethanol per hour. So a 120 gallon per hour falling film evaporator will cost you a pretty penny. So we can do solvent recovery as much as you want, cheaply, at room temperature, which is really important because you don't have to heat your solution, and so there's thermal degradation, maybe some isomerization that happens when you're putting these things through a rising or a falling film evaporator, right? You're going to decarboxylate, etc. So if you don't want to decarb, get a membrane filter. Then you can do terpene isolation. So there's actual membranes that can separate terpenes, just allow terpenes to permeate out from your crude. You can do sugar removals. We have certain ceramic membranes that can just specifically remove sugars from your crude. So if you've got sugar problems, we got you. The other thing is winterization membranes, misnomer, but our winterization membranes effectively can remove 95% of fats in your crude. And they can do that at reasonable temperatures. If you're doing ethanol, we can remove 95% of fats at about 0 Celsius. If you're using methanol, you may be able to go up to 25 Celsius at a much faster rate and still remove 95% of your fats. And the cool thing is that you can remove other stuff. Carotenoids, flavonoids, you can remove some chlorophyll, lipids, fats, waxes, some gums, all kinds of things. The important thing about the winterization membranes, I think they're more of a remediation type of thing. The important thing is, hear me out. I personally ran the nastiest crude I've ever found. It was a warm ethanol extracted, one of those screw presses, nasty stuff. I mean, it's just nasty, nasty, nasty. You put these things through a wiper, I'm telling you, 10, 15 minutes, my wiper is clogged. Forget about it. After you run the same crude through a membrane, a winterization membrane, that's it. No worries. You can continuously run this disgusting, crappy crude through your wiper without any clogging, without any problem. So that's what most people are looking for when they refer to the winterization process. And so that is just genius. So, can your machines perform remediation and desolvation simultaneously? No. No, you can't. The cool thing about our machines is that the function is not performed by the machine itself. It's the membrane that does the work. So that's really important because you swap out a membrane and you can do solvent recovery, you can do terpene isolation, you can whatever, right? So it's the actual membrane. It's the little cartridge that goes inside the machine that does the actual function. So, when we first started, you could do solvent recovery at like 30 gallons per hour. Right now we're sometimes at 120 plus, depending on the application, whatnot. And so the cool thing is that as research progresses, better machines are identified, better membranes are identified. Swap out a membrane and you will be able to have better performance from the same machine. But that being said, you can't do two functions at the same time. So the membrane actually does the function, not the machine. You can swap out the membrane to do solvent recovery, winterization, whatever. But it's not really practical to swap out a membrane. So how we get around that is we have a duplex function. So these machines have X amount of tubes. So these tubes here are where the membrane goes in. And so typically a machine will have the most efficient configuration is 4 tubes, and they do the filtration function, what have you. And to get around, you can either, if you want to do solvent recovery and desolvation, you need 2 machines because the membrane does the function itself. Or we have these types of machines that have 2 sets of tubes in the same machine. But because of limits on pressure, the pressures on the different membranes, they're very specific to the membrane, and there's just really no way to have like a stage, like first solvent recovery, then winterize. It doesn't really work. So what we do is we have a valve. And so you flip this valve over and you're going to go from winterization to solvent recovery or whatever, because the flow just goes from one set of membranes to the other set of membranes. And so it's a few extra bucks to add that duplex type of functionality, but that really does save you a ton of money and lets you have that flexibility of having 2 functions in one machine, if that makes sense. Is it practical to swap membranes for desolvation and remediation on the same machine? No, not really, because it's not difficult to put the membranes in, but my main concern is that if you're careless, you'll bump the membranes, you'll break them, you'll scratch them, or you let them dry out, and you can just ruin a membrane. So honestly, yes, it can be done, but it's not exactly practical. With some practice, you could probably do a swap out in 15 to 30 minutes. If you did 1 week this, 1 week the other, perhaps, but not on a daily basis. What's the life expectancy of membrane modules? So there is no research. If you call the manufacturer of these membranes and say, hey, listen, how long does this last? They got nothing. They're not going to be able to give you a straight answer because there is no data to support it. What I can tell you is that on the membranes that we've placed out in the market, you can expect somewhere from 6 to 18 months of use. It's just really hard to say, how many gallons people are actually filtering through these things and what their SOPs are. Are they actually cleaning them every time they use them? They're following our recommendations on how to actually use these things or not. So, it'll depend. But the important thing is that a membrane is $600. Lenticulars, $275, $235. I have customers that run through $10,000 worth of lenticular filters a month. Your consumables expenditure is going to be just a drop in the bucket. There's just not a lot of money being spent on these filters because it's just a different technology. Just there's a big difference on how they work because a lenticular filter, the garbage, the wax, all those particles, they accumulate on the filter, and so there's only so much that you can use them. Membranes are so different because you have one pipe coming in and two pipes coming out. You could have your permeate and your concentrate. And so your concentrate is, for example, the fats that accumulate. Your permeate is whatever makes it through the membrane. That's going to be your clean. It's going to be your clean ethanol, your winterized solution. And with this cross-flow function, it's like a self-cleaning filter. So really, you could get a year out of these membranes for $600. You really can't beat that. I mean, how is it possible for membranes to last such a long time? It's exactly what I'm talking about, right? That they're self-cleaning. They're self-cleaning. That's a thing called cross-flow, tangential flow. You can read up on it, but it's really cool. They clean themselves. The garbage, the particles, the fats, the whatever does not accumulate in these filters. They just go out the other end, right? Clean goes on one side, and then the dirty goes the other end. Concentrate, retentate, or permeate, so on and so forth. Can I use any brand of membranes? Yeah. Yes, you can. So, again, the machine is very flexible and you have a wide operating parameter that allows you to have membranes of different flow rates, which you can control, pressures that you can control. And so you can use any brand. And so the cool thing about our systems is that, just as we've done, like I said, when we started, we were doing 30 gallons per hour desolvation, and now we can do 100 plus on the same exact machine. What changed was the membrane. So, some companies are kind of wonky, but most of them are very standardized. If you may need to use an adapter, but yeah, you can use a lot of standardized membranes. Is pre-processing required before using membrane filters? Yes, you got to pre-filter. You got to filter the stuff and get all those big bits down, 10 microns or whatever. You can use a filter press, which is what we recommend. You can use a candle filter, which we recommend. You can even use a bag filter, which I don't particularly like. But solvents, what solvents can I use? This is compatible with iso, methanol, ethanol, pentane, hexane, heptane, all of that stuff. No worries there. The main concern is the membrane that you're using. Like if it's polypropylene, you got to be careful with the chemical compatibility of the membrane, but the machine itself. But we have membranes that are compatible with all kinds of different options depending on the application that you are using. What percentage of solvent is recovered from my Micellar stream? 90%. So yeah, at the end of that filtration process, you're going to have to reprocess. Typically, if you're going to decarb or something like that, you have a small bit because you cannot filter crude. Crude is so thick, it's got to be dissolved a little bit. So, this will get you 85-90% of the solvent removed. What's left is really marginal and can be removed with a rising, a falling, a rotary evaporator, a decarb reactor. We got all those for you if you need them. Can I remove water from my solvent? No. This is not reproof. It's totally different technology. We got you if you need it, but if you want to do membrane-based reproofing, the actual solvent needs to go into a vapor phase. Man, it's So for all intents and purposes, no, it's a different machine, but membranes can be used. Does filtration occur in series or tandem? It occurs in series. We do have some systems that go in tandem, and it depends on your application. But basically, fluid goes into filter housing number 1, and then 2, then 3, then 4. There's a pressure drop in each housing, about 15 psi or whatever. So every housing, you lose a little bit of pressure. So remember what I said, you can't have a duplex function if you're doing solvent recovery. You might be at 600 psi. With winterization, you might be at 150. So if you start in this membrane with 150, by the time you go into this one, you're at 135, 120, 105. And so the fourth membrane is not going to permeate as good as the first membrane because you don't have the pressure. And so they would not be compatible if your next step was like a higher pressure application. So that's why you can't have that duplex functionality in series, right? But they do function in series. So the different sizes of membranes, really simple. A 2540 membrane refers to the diameter of the membrane and the length. So you have a 2540 means 2.5 inches diameter by 40 long. You have 2580. You have 3838, which means 3.8 inches diameter by 38 inches long, so on and so forth. 4040, 4 inches diameter by 40 inches long. You get it? What are the flow rates for solvent recovery or remediation? Okay, most of the systems for hemp and cannabis are going to be in the 2.5 inch. Some of the larger operations will go with a 4 or an 8 inch system. The 2.5 are manual. The 4 and the 8 can have PLCs. We do have PLCs on 2.5 inches, but the PLC and mainly the sensors that go to the automation are extremely expensive. But so if you're doing solvent recovery, depends, right? You can get somewhere between 90 to 120 gallons per hour of ethanol. If you're doing methanol, it's a lot faster. Some of the other hydrocarbons are a lot faster. Winterization is still stuck at somewhere about 30 gallons per hour, but it doesn't matter because when you do winterization, if you stage them, like if you do solvent recovery first and then you do winterization, they catch up to each other. Why? Because if you're at 50 to 1 or whatever, 20 to 1, when you're done with solvent recovery, it's going so fast. And then you go to winterization and you want to be a continuous processing line. You want to go straight from solvent recovery to winterization. When you're winterizing, we winterize at 4 or 5 to 1. So you don't need 100 gallons per hour to be able to manage that feed, right? Which you're not going to have. You're going to have somewhere around 30 gallons per hour. So they will line up just because you start with a lot, but you're moving really fast. And then, you have less volume, but you can't winterize it as fast. That being said, you do need to modify the temperature. Winterization will happen somewhere between 0 to 25 degrees Celsius, depending on the solvent used. The solvent recovery, the warmer the better. ASME. So, note to self. You do not get ASME stamped vessels unless they are 6 inches or above. So the 2.5 and the 4, they simply cannot be ASME because they're not classified as pressure vessels as such. So, but the 8-inch systems, definitely they are ASME stamped. Remediation. What do they remove? Again, the point being is that you can have really nasty, dirty crude that clogs up your wiper in seconds. and then run it through the membrane at a 4-to-1 ratio, and your problems are solved. That's the gist of it. 95% of the fats, you can remove lipids, fats, waxes, chlorophylls, carotenoids, gums, phosphatides, phospholipids, water-soluble compounds such as sugars, etc., yada, yada, yada. Can you remove THC from CBD? No. Simple. What percentage of fats are removed from the micellar stream? 95%. Can you remove sugars? Like I said before, yes. What are the losses associated with cannabinoids in the remediation process? That is a really good question. What do you think? So I'll dive a little bit deep into this because it's very interesting. So maybe a little bit hard to follow along, but remember when I said that you can't pump straight up crude through the system? It's got to be dissolved with something, right? So you always got to have some kind of solvent in there. And if you're doing some sort of remediation, let's say you're at a 4 or a 5-to-1. Okay. So in this example, you're going to be removing contaminants at a 2-to-1 ratio. Okay. So if you're starting with 1,000-gallon stream, that's 5% fat. That means that 50 gallons of that are going to be fats, right? So if you want to pull out, let's say that you were pulling out 100% of the fats, which you're not, you're going to be pulling out 95% of the fats. Say that you pull out 100% of the fats, you're going to pull out 50 gallons of fats. But you can't just pull out 50 gallons of fats because you can't pump out 50 gallons of fat. They have to be dissolved in something, and they're going to be dissolved in the micellar. What is the micellar? Is your mixture of solvent and crude. So at a 2-to-1 ratio, that means you're going to have 50 gallons of fat that are going to be mixed with 100 gallons of micellar. So the 50 gallons is garbage. The 100 gallons, there's money there, right? What permeates or makes it through the membrane, that goes on to your next process. That's said and done. So from the initial 100 gallons, you're stuck with 150 gallons of stuff that you need to do something with it. Depending on the economics of your operation, you might say, I can't throw away those 100 gallons worth of stuff because if it's at a 4-to-1 and I have 100 gallons of micellar in there, that means I have 25 gallons of crude. It's significant, right? So what do I do with these 100 gallons? Simple. You dilute that 5-to-1, and then you reprocess it. So from an initial mass of 100 gallons, that gets diluted and gets reprocessed through the membranes. And then your loss, instead of being that, in this case, it's at 10%. Again, this is very dependent on the percentage of fats because there's always going to be that 2-to-1 relationship. So anyways, those 100 gallons get diluted, they get reprocessed. And again, you're still going to have that 2-to-1 ratio. You're still going to have the 50 gallons of fat, but that micellar gets diluted. And so when you reprocess it, you may only have 1%, 2%, 0.5% of loss, if you follow me, right? So then when you reprocess it, you process this thing 2 times. Then you can say, is it worth that liter or gallon of crude that is in that micellar that's still trapped with those 50 gallons of fats or not? It may or may not be, depending on what you're processing, the scale that you're processing at. Look, typically what happens is with customers is they just save their fats. They save their fats and they reprocess everything together when they have a substantial amount of fats that need to be reprocessed at a later date. And that's how that's done. Another way you could do it is, because the volume is so much lower, you stick them in a freezer and you can run them through a filter trolley, a filter press, and just do a regular winterization. Because there's such a high concentration of fats, they coagulate and they drop out so easily. So it's just really easy just to get most of those fats out of there with regular refrigeration. Again, it really depends on your operation. It's not a loss until you discard it, right? So with a filter press or with a filter trolley, it really isn't going to be a problem. And then you can remove 90% of those fats that congeal through a filter press or a filter trolley. And then if you still wanted to reprocess that micellar through a OSN and get that cleaned up at the same level as your previous batches, you can do that. And that's the most cost-effective way to do it. There's no way to do it. The reprocessing, there's no way to do it continuously, but typically customers will just accumulate those batches and then just reprocess them all together, or they can reprocess them through the typical standardized winterization process, which, because the volume is so much less, it's just so much easier to process than, say, sticking 1,000 gallons in a freezer for God knows how many days until you get that cold enough temperature to have all those fats crystallize. And how do we recover the losses? I just explained that to you. Is refrigeration required in the remediation process? Yes. So this is a choice that's really up to you, and it depends what your final product is, the kind of quality that you're looking for. But hear me out. In the end, you want this to run through your wiper. You want it to be winterized. So you have to decide, is it worth it for me to process at such a cold temperature or not? We find that at 0 Celsius, if you're running ethanol, you will remove 95% of your fats. If you can't process at 0 Celsius, you could process it warmer, but there's a curve. So you have to really find out how your crude behaves. The other option is, if your jurisdiction allows you to use methanol, you can dissolve your crude in methanol and then process that as high as 25 Celsius. And you're still going to get whatever, 25%, 95% of your fats out of that. Why? Well, that has to do with solubility. And we have a link to an article on solubility, and it really explains that. What is the ratio of dilution for remediation? I said that previously, 4:5:1. What solvents should I use to remediate? Awesome. Methanol has a Hildebrand solubility parameter of 36.2, while ethanol is 26.2. Wow, that is a mouthful. The point being is that fats don't dissolve in ethanol as easily, in methanol, as easy as they dissolve in methanol. So if you use methanol, it's just not great for dissolving fats, thus makes it easier to filter. And you don't need to go so cold as a consequence. Can I extract at room temperature and remediate with membrane technology? Yes, absolutely. That is the whole point. I told you. These guys, I saw this crude where they were taking just, warm extracted crude, and they were using one of those screw presses, and this stuff was just nasty. The wiper was just clogs up in seconds. Run it through a membrane, a winterization, a remediation membrane, straight through the wiper, no problem. How much power do the machines consume? There we have a chart where you can do like a cost calculator based on how many gallons per hour, electrical consumption and whatnot. But you can see on the screen that ideal batch size for the smaller systems, 25 gallons. There's cleanup procedures that you need to take into account. So if you've got like 5 gallons, this is not for you, but barrel on up. Yeah, sure. Terpene isolation. Yeah, we got you. Why pick us? Why? Because we take the time to educate. Our stuff is amazing. Continuous product development, and we just test membranes all the time. And you know who we are. If you're interested in a membrane, all of our products are on our website. Prices are on our website. You can take a look at the basic system. It's here. Then the duplex, that's just like the double stacked system where it has 8 housings instead of 4, so on and so forth. Then we have the 4-inch, the 8-inch, PLC, no PLC, And the membrane prices vary from manufacturer. But if you have any questions, fill me out. If you have any questions, just drop your comments in the comment section. And if there's a topic that I didn't answer in this video that you think I should be addressing, if there's some questions that I should be addressing and there's something that you want to know, just drop your comments below, and I would love to really just hear what the community has to say and make another video. And is there other subjects that I'm not touching that you think I should be addressing? I would love to hear about that. And thanks for watching, guys. I really appreciate your time, all you guys that listened to my ASMR video today. I hope you enjoyed the conversation. If I put anybody to sleep, I'll take that as a win, because we all need our rest. And I really had fun. I had fun making this video. Great cigar, great beer, wonderful audience. Nobody complains. Nobody says nothing. All right, guys. Thanks for watching.